Hello viewers, I'm Kausalya. Today we are going to solve problem 3. The problem is find the driving point admittance of the network shown. So here this is the given network. In the previous problems we have calculated the value of impedance, but now here we are going to calculate the value of admittance. So what is the relationship between admittance and impedance? They are reciprocal of each other. So here when you look at the given circuit diagram, totally it has 3 loops. So here we are assuming the current by ourselves. So I1, I2 and I3 be the currents that flow through these 3 loops respectively. So here you see we are having only one voltage source and that voltage source is connected with our loop 1. So now we are going to write everything in the form of a matrix. So as we all know, V is equal to I into Z. So now we are going to write in this format in the form of matrix. So in the matrix method, again you see we are having only one voltage source and that voltage source is connected with loop 1. Therefore here you see the values are, the first loop has a voltage source V1 and there are no voltage sources in loop 2 and loop 3. Therefore, here it is 0. And the next thing is, here we are having 3 loops. Therefore, the value of the impedance matrix will be of the form 3 by 3. So, here, how to write the values? I believe you people know. So, let me explain. So here, that is the diagonal elements, they cover the sum of the resistor values in that particular loop. For example, you see it is 1, 1, right? So sum of resistors in the first loop. So here you see totally we have 3 resistors. So when you add 10 plus 4 plus 8, that gives 22. So this is what I had written here. Again, when you look at loop 2, you have to add all these 3 values. So 10 plus 2 plus 4, so that gives 16. So here you see 2, 2, it is 16 here. And the next one is 3, 3, which is this place. So sum of resistors in the loop 3. So 2 plus 10 plus 4, that gives 18. So here I had written the values. Now we are going to write the resistors that are common to loop 1 and 2 as well as loop 1 and 3. So now this is your loop 1 and this is your loop 2. Which resistor is common? Here 10 ohm is common. Now look at the direction of current flow. I1 flows through this resistor like this and I2 flows through this resistor in the opposite direction, right? So here the value of the resistance is minus 10 because the currents are opposite to each other. Again, when you look at the resistor which is common to loop 1 and loop 3, it is 8 ohm. Again, you see I1 flows like this, whereas I3 flows in the opposite direction. Therefore, here we should write it as minus 8. So, here it is minus 10, minus 8. Similarly, here it is minus 10, minus 8. Now, we are going to find the resistor which is common to loop 2 and loop 3. So, this is your loop 2 and this is your loop 3. So, in loop 2, you see, here the common resistor is 4 ohm. So I2 flows like this and I3 flows in the opposite way. So here it is minus 4. Now we have completed this matrix and here the respective current flowing through the loops are I1, I2 and I3. So this is the important step. Once it is done, check one more time and then proceed. Now we are going to find the value of del. So del is nothing but finding the determinant value of the impedance or resistors. So here we are going to find the value. So I believe again you people know how to take the value, right? Determinant. So first element is 22. You have to leave this column and this row and you have to multiply this element minus of, you have to multiply these two. So you see 22, 16 into 18 minus of minus 4 into minus 4. And the next thing is we are moving to this part. So here we have to include a negative sign. So minus of minus 10 had become plus 10 here. Again you have to leave this column and this row. So how you can multiply? Minus 10 into 18 minus of minus 8 into minus 4. And finally here it is minus 8. So you have to leave this column and this row. So minus 10 into minus 4 minus of minus 8 into 16. So this is what I had written here. So as usual you have to multiply. So here you see, when you find the value of this thing, I am getting the answer as 272. And similarly for this term, it is minus 212, and when you solve this term, we are getting 168. So here when you multiply and simplify, we are ending up with the answer 2520. This is your value of determinant del. So del is 2520. The next one is finding the value of del 1. So here in the determinant, you have to replace the first column. You see here, this is the value of the determinant. So in order to find V1, you have to replace this first column by this voltage value. So this is what I had written here. So you see V1, 0, 0, and the rest of the columns, they remain the same. So again here, we are going to find the determinant of this del 1. So as usual, here it is V1. So you have to leave this column and this row. So V1 into 16 into 18 minus of minus 4 into minus 4. So again 16 into 18 is 288, and here minus 4 into minus 4 becomes plus 16, and here there is a minus sign. So minus 16, therefore here the answer is 272 V1. Right. Now we are going to find I1. So I1 is nothing but del 1 by del. So we know the value of del 1, and we had already calculated the value of del. So just substitute it here. So here we are getting the answer as, okay, let this be remain as such. Right. What we need actually, we need impedance. Right. We need actually admittance. Now we are going to calculate the impedance, and then we are going to proceed with the admittance value. So here, you see, you just leave this. Look at these two terms. I1 and V1 are related. So what is the formula for impedance? It is V1 by I1. So just rearrange this expression. So V1 here, I am bringing this I1. So here it occupies the denominator part. So V1 by I1. So when you move these numbers to the left hand side, they just become the reciprocal. So here they become 2520 by 272. Therefore here the answer is 9.265 ohm. So this is your value of impedance. So always keep it in mind. You are asked to find the admittance. So here you have to take the reciprocal of this number. So when you take the reciprocal of this number, you see the value of Y1 is 1 by Z1. So 1 divided by 9.265 gives the answer 0.108. Okay, here it should be mho. Okay, the unit of impedance is ohm and the unit of admittance is mho. So always, be cautious while writing the unit. Right. So again, this is a simple problem. Here the main concept is you should be very clear in writing the expressions, right? Writing the matrix. Once the matrix is done, check twice, okay, whether you have written everything correct, and then proceed with calculating the value of determinant of del and determinant of del 1. And when you find the ratio of V1 by I1, that gives Z1, you have to take the reciprocal to find the admittance, and the respective unit of impedance is ohm and admittance is mho. Right. That's it. If you have any doubt, let me know in the comment section. Thank you.